Welcome to the Lincoln Electric Welding Safety Series. Whether you are a new welder, a hobby welder, or an experienced pro, it is important to understand how to weld safely. You'll meet my friend David as we learn safe practices regarding the following topics: electric shock, gases and fumes, fire and explosions, general workplace safety for various conditions, engine exhaust and trailer safety, warning labels and safety documents, personal protective equipment, and torch cutting and CNC plasma cutting. Let's get started. Hello, David. Are you ready to learn about electric shock? Good. Electric shock is one of the most serious and immediate risks facing a welder. You can receive an electric shock when you touch two metal objects that are electrically hot. David, in front of you is a live wire that's been severed. If you were to touch both wires... David, I said if. Please, listen carefully. If you were to touch both wires, your body would experience an electric shock. Thankfully, the voltage across these particular wires is relatively low. But let's pretend for a moment, David, that you are up high, like on a ladder. David, no. Don't climb the ladder. I'm saying, let's pretend. If you were high on a ladder, even a low-voltage shock could very well startle you enough to send you falling, likely resulting in gruesome permanent injury or even death. Don't worry, David. Stu is a cartoon and can recover from any injury. The severity of an electric shock is greatly influenced by the magnitude of the current flowing through your body. Also important to the severity is the type of current producing the shock, alternating current or direct current. Didn't pay attention in physics class, did we? Well, let's try illustrating it another way. This is Brian. Brian is a low-voltage direct current. If you were to come into contact with Brian, the initial shock to your body may not be severe. However, if you were to remain in contact with Brian for an extended period of time, the chance of bodily injury increases. Thankfully, you're able to let go of Brian at any time. However, we've invited your friend Ted to be high-voltage alternating current. If you were to come into contact with Ted, not only would the initial shock be extremely dangerous, but alternating current can also initiate uncontrollable muscle contractions that can create an inability to let go of Ted and even stop your heart. This is a potentially deadly situation. Go ahead, Ted. I know you don't want to do it, but we're teaching valuable safety lessons here, and it's important to demonstrate so that David really gets it. Thank you, Ted! There you are. You see, David, in welding, you will encounter both alternating current and direct current at varying voltages. All can be very dangerous, even fatal, under certain circumstances. An electric shock received while welding can range anywhere from 20 to 100 volts and is called a secondary or welding voltage shock. The voltage inside of welding equipment, however, is commonly much higher, ranging from 120 to 575 volts or greater. An electric shock of this magnitude is called a primary voltage shock and is more than enough to cause severe injury or death. Now, David, there's no reason to be afraid, but it is important to clearly understand the risks involved when working with electricity so that you can take the proper safety precautions to ensure a long and safe career in the welding industry. Ready to continue, David? Great. Let's discuss primary electric shock. Primary electric shock is very dangerous because it is a much greater voltage than secondary or welding voltage. Remember Ted and Brian? Of course you do. Primary electric shock is Ted. Now don't worry, David. We're going to talk about how to prevent you from coming in contact with Ted. You can receive a primary electric shock by touching two electrically hot wires, or if you touch a lead or other electrically hot component inside the welder while touching the welder case or any grounded metal while the power is on. Nice try, David. But turning the welder power switch off does not turn the power off inside the welder. To turn off the power inside the welder, you must unplug the welder or the power disconnect switch must be turned off. Very good, David. Now, was your welder installed by a qualified electrician? Oh, David. Your welder should be installed by a qualified electrician so that it's connected to the correct voltage and is properly grounded. If the welder is not connected in the right way to the power source, the case of the welder may become electrically hot, which can be very dangerous. But when a case is properly grounded, a fuse will blow if a problem occurs, disconnecting the power and letting you know that it's time for a repair. Are you satisfied? Would you like me to turn the power back on? Are you sure? Okay. David, do you see where you went wrong and put yourself in danger of a primary electric shock? Thank you, Ted. You closed up your welder case, which was very good, but repairs should always be done by a qualified technician, and you are not qualified to perform repairs. But now you've learned something. I think we all have. Perhaps I should have started you off with secondary electric shock, which is usually a bit less severe. Secondary electric shock happens when your body completes the circuit between your electrode cable and the metal you are working on. Remember, David, electric shock can kill. Don't touch electrically live parts or electrodes with skin or wet clothing. Develop safe work habits. Make sure your skin is fully insulated from the area you're working on and from any grounding source. Always wear dry gloves in good condition. To make sure you're being properly protected, you need a helmet. Very good, David. Oh, I almost forgot. Are you wearing a wedding ring or any metal jewelry? Ah, yes. Those have to go before welding. Don't worry, you can put them back once we've finished. There we go. Sometimes welding must be performed under electrically dangerous conditions, such as damp locations, on metal structures like floors, gratings, scaffolds, or ladders, or in cramped positions. When working in conditions like these, or any situation in which there is a high risk of unavoidable accidental contact with the workpiece or ground, use the following equipment: semi-automatic DC constant voltage welder, DC manual stick welder, AC welder with reduced voltage control. Always inspect your electrode holder before turning the welder on. Go ahead, David. Sorry about that, David. My bad. The plastic or fiber insulation on your electrode holder protects you from touching the electrically hot parts inside. If the holder is damaged... Now, David, you're not MacGyver. Replace the holder if it is damaged unless you have replacement parts. Also, examine your cable. If any of the insulation on your cable is damaged, it is possible to repair it. Now, David, you can repair it using good electrical tape. But you must check your local codes for the tools you're using and the type of work you're doing. It may not be permissible to repair your cable. You may have to replace it. Now, your electrode holder and cable are in perfect order, David, so you're ready to rock. Remember, a stick electrode is always hot, and the voltage is highest when you are not welding. This is called open circuit voltage. Oh, David. Always treat your welder with respect. Welding can be very safe as long as you practice safe work habits and keep your environment as low risk as possible. Hi, David. Nice to see you again. Are you ready to continue? David, I don't quite know how to tell you this, but We're going to talk about fumes and gases, and I'm afraid your outfit, while quite charming, isn't going to be much use against those. Let's begin. Arc welding fumes contain small particles from the consumables, base metal, and any base metal coating. Arc welding gases come from the shielding gases used in certain welding processes, like shielded metal arc welding, or SMAW, and gas metal arc welding, known as MIG or GMAW. Gases can also be formed from the flux during welding. You can go to lincolnelectric.com to view a list of the potential respiratory problems and other health hazards associated. David, really? This is serious. Okay, sure. Technically, if you were welding underwater, you might wear a scuba outfit, but that's not the typical way you would protect yourself from fumes and gases. Please, take that off. The information about hazards contained in warning labels can change periodically, so it's a good idea to keep up to date. You don't want to be late to the party, David, do you? David, are you there? No, there's no party, David. I just said you don't want to be late to the party. It's a metaphor. Oh, heavens. David, do you know what an SDS is? It stands for Safety Data Sheet, and there is an SDS for every Lincoln Electric consumable welding product. You should review the SDS for every product you use so you know what you're being exposed to. The SDS contains important information about the compounds used to manufacture the product, fire and explosion hazard data, health hazard data, reactivity data, and information on the precautions to use for the safe handling and use of the product. Don't worry, David. The SDS for any Lincoln Electric product can be obtained by your employer by using the QR code on the package, or found at www.lincolnelectric.com/SDS. This online version contains the most up-to-date product information, so even if you have the paper version, be sure to check online from time to time. David, are you surfing the web? Come on, we're not done with this chapter yet. In addition to reading warning labels, you must always inspect your welding environment and conditions. Make sure you have the proper ventilation, which we'll discuss in the next chapter, and know the composition of the base metal as well as any painting, plating, or other coating. The first and easiest way to do this is to obtain the SDS for the base metal you'll be working with and remove any paint, plating, or other coating. If you can't obtain the SDS or don't know what's in the coating and cannot remove it, it's time to call on science. David! That's not... Please don't do that. This is Dr. Science. Dr. Science? Really? That's what we're going to call this guy? Anyway, have the base metal evaluated and the fumes sampled and analyzed by an industrial hygienist to determine what compounds are in the fumes and to measure the amount of exposure to those compounds. No, Doctor, you're fine. David thought we were having a party. Never mind. We'll talk more in the next chapter about how an industrial hygienist works. You see, David, it's all about exposure. There are guidelines for how much exposure to potentially hazardous chemicals is acceptable. In the U.S., OSHA has created the Permissible Exposure Limit, or PEL, and ACGIH has created the Threshold Limit Values, or TLV. This information can be found on the SDS, and keeping your exposure below these numbers will keep you safe. The first and most basic rule is to keep your head out of the plume created by your welding. This may seem obvious, but failure to do so is a common cause of overexposure to welding fumes. This is George. George is an alligator. Imagine George's head is the plume from your welding. Never stick your head in the alligator's mouth. Okay, George, let go. I think he's learned his lesson. Keep your head out of the plume. Right, David? Furthermore, you must always ensure proper ventilation. The major types of ventilation are as follows. The first is natural ventilation. If you're outdoors, this would be wind. Indoors, this would be windows and doors. The second type is mechanical ventilation. This would be fans. Finally, local exhaust sucks the fumes and gases away right at the source of welding. Local exhaust can be provided by any of the following: fume extraction guns, fixed enclosures, downdraft tables, or booths with exhaust hoods, adjustable elephant trunk exhaust systems. There are many ways to position an elephant trunk exhaust system, and it depends on your welding conditions and setup, as well as the angle of your weld and your position relative to the work. Determining which type of ventilation is right for a particular welding job is based on the following factors. First, the size and configuration of the welding space you're working in. Next, the number of welders in the space, welding process and current, the consumables used and the material being welded, including paint or plating. And finally, the PEL and TLV exposure limits, which can be found on the SDS. When adequate ventilation can't be provided, you'll need to wear a NIOSH-approved respirator. Don't worry, David. You aren't expected to be able to figure all this out on your own. This is where Dr. Science comes in. Nice of you to join us, Dr. Science. No, Dr. Science, most stylists and manners gurus believe you can never be overdressed. But that's a topic for another set of videos. Let's continue with this video. Whenever you're working with potentially hazardous compounds, an industrial hygienist should sample, measure, and analyze the compounds you're being exposed to while you are welding. Now, David, this is all very official and should make you feel quite safe. But remember, use your common sense and trust your body. If the air you're breathing is not clear, if your breathing air is not comfortable, or you're starting to feel crappy, you may be overexposed. Stop welding and get fresh air. Let your coworkers and supervisor know what's going on. And if symptoms persist, see a doctor. A real doctor, David. Sorry, Dr. Science. Industrial hygienists are respected professional scientists, but they're not medical doctors. And I said this before, I didn't think this was the best name for him. It's for one thing, it's not creative. It doesn't come off the tongue very nicely, and the people watching this lovely video you're putting together are going to notice that it's poor craftsmanship, really, is what you're talking about here. And you're talking to craftsmen, to the welders. They're not going to appreciate this. Let's talk about fire. The welding arc can reach a temperature of up to 10,000 degrees Fahrenheit. Do you know how hot that is, David? It's really f***ing hot. Think the arc is the main fire hazard? Think again. The fire hazard comes from the sparks and spatter of molten metal created by the arc. You know the pretty orange lights and sparkle that happen when welding? That's what I'm talking about. Yes, David, it looks very much like a firework, but the spark and spatter from a weld is much hotter and much more dangerous than what you've got there. So when considering ways to celebrate your country's birthday, consider over-the-counter fireworks and keep welding in the workplace. Did you know that sparks and spatter can spray up to 35 feet from the area in which you're welding? You've got to remove or protect any flammable material within a 35-foot radius of where you'll be welding. Is any fire dangerous? You bet. Does every fire start in a burst of flames? Not a chance. A spark that comes in contact with flammable or combustible material can smolder, burning the material slowly over time. You might not notice it at first, like the girl in the movie who wears glasses, until she takes them off and you realize, whoa, she's hot. While you're welding, your workpiece can become extremely hot, so make sure it's not in contact with anything flammable that may burn when heated. Some materials that can turn your workplace into a disco inferno are solids such as wood, cardboard, and paper. Watch out for those wooden pallets that materials come in. Those are always lying around work sites. Liquids like gasoline, oil, paints, and thinners. Used rags gather quickly and often go ignored. Remember, they could be soaked in highly flammable liquid. Gas like acetylene, propane, and hydrogen. But these are just a few examples, so keep your wits about you. If you don't know whether a substance in your workplace is flammable or not, how do you find out? Not like that, David. Contact the head honcho, the big G's, the top dog, and get approval. If the material is flammable, you better remove it. If you can't remove it, protect it. How do you protect material that can't be moved? Carefully. Use a piece of sheet metal or a fire-resistant blanket and don't cut corners. Burning is irreversible. If you're welding within 35 feet of flammable material that can't be moved even once you've protected it, you need a sidekick. This is Francis. He'll be your fire watcher. He'll watch where your sparks are flying and grab a fire extinguisher or sound the alarm if things go down. Which they won't, because you've removed or protected every potential hazard, right, David? I know you did. You and the fire watcher need to stick around a full half hour after welding is complete to make sure there aren't any smoldering fires you didn't see. This is a great chance to work on your small talk. Working on an elevated location? Look out below. You may need to increase that 35-foot range to account for falling sparks. And hey, make sure there's no one working below you. No one appreciates a spatter shower these days. And lastly, working in a dusty location? Take extra care. Under certain conditions, fine dust particles may be combustible and can burn without warning. Guess what? That's called a flash fire. Or worse yet, an explosion. Know your welding environment. Only experienced welders should work on piping or closed containers that may contain combustible materials. For work like this, you need to read up. I recommend starting with the American Welding Society document F4.1, Safe Practices for the Preparation of Containers and Piping for Welding and Cutting. With a title like that, you might not want to suggest it for your book club, but you will find it essential in setting up to weld on closed containers or piping. You see, when working with containers that may hold or have held combustible substances, you might need to fill the container with an inert gas or water. And if you don't do that just right, kaboom could be the last sound you ever hear. Let's review some basic fire safety. 1. Know where the fire extinguishers are, that their pressure is sufficient, and that you know how to use them. 2. Know where the fire alarms are. And 3. Know where the fire exits are. No fire extinguishers around? Make sure there's a fire hose with water pressure, sand buckets, fire-resistant blankets, or other firefighting equipment. Welding without appropriate firefighting equipment on hand is like showing up to book club without reading the material. You'll look like a jerk, and you won't get invited back. Or in the case of fire and explosion safety, it could be much worse. Step 1 of basic fire safety, be prepared. Let's take a look at step 2. This is a panic button. As we all know, the first rule of any emergency is do not panic. David! Well, David, it looks like you cannot resist pushing any button you see. We've removed the panic button and replaced it with a do not panic button, because a panic button should never be used. Let's review what to do if there is a fire. First, remain calm. Is the fire small enough? You can try to put it out with a fire extinguisher. You know how to use that puppy because you reviewed the instructions on it before you began welding. Always aim the fire extinguisher at the base of the fire on the material that's burning, not on the flames. If the fire is too large, call the fire department, sound the fire alarm, and let the other workers know. Shut off your welder and get the heck out of there. David, you've taken the do not panic idea to the next level. Thanks. Very helpful. Most fire safety precautions are common sense, but you may need additional safety training and certification depending on the job. Consult your employer or safety director. Warning! Danger! These are the signs you'll see on warning labels. Warning labels appear on tools and products that you use when welding. They're there to, as you may have guessed, warn you. These days, it seems everything has a warning label, from car seats to microwaves to a roll of toilet paper. But that doesn't mean you shouldn't read them. Warning labels on your welding equipment and products contain important information you need to know. Please read them carefully. There are 3 main sections. Number 1, the signal word. Do you know what that is? Warning is a level 2 signal word, while danger is a level 3 signal word. Where's level 1, you ask? Level 1 should be your default level of caution, your baseline alert status whenever you are welding or preparing to weld. David, could you please move to the side? You're blocking the screen. Thank you. Where was I? Signal words. Okay, after that. Section 2, Statement of Hazard. This lists the specific dangers to the product or tool you're using. Number 3, Hazard Avoidance Instructions. This is where you'll see the safety precautions you should take to avoid the specific hazards. Read the labels. They might also contain references to additional safety regulations from OSHA, or the appropriate governing body for workplace safety in your country, and industry safety standards, notes about specific compounds in the welding fume which require additional ventilation, and where to go to get more information about the product. David, always practice caution so you don't have to be warned about dangers. And don't step in front of the screen. If you ever have a question about a product or tool you're using, go to lincolnelectric.com to find out the latest. Let's talk about how to read an SDS. SDS stands for Safety Data Sheet. It used to be called an MSDS for Material Safety Data Sheet, but we dropped the M to make it leaner and more hip. The new SDS is a 16-section document that is sent electronically to a customer and can also be found at lincolnelectric.com. Inside all Lincoln Electric consumable welding products, there is a safe use guide, which gives you information on where to find the SDS for a particular product. You can also use the QR code on the package. Okay, David, can you please move away from the screen? You know what? It's okay. We'll just go full screen to the shots of the SDS. Section 1 has the name of the manufacturer, the product type, and the name and identification number for the product. Pretty straightforward. Section 2, Hazard Identification, provides an overview of the hazards associated with the particular product. David, how are you even doing that? Why don't you look at an actual SDS? There are some on the table. Section 3 is a breakdown of the hazardous ingredients in percentage by weight in the unused product. I'm talking about this section here, David. Don't worry, most of this information is for use by your industrial hygienist. Section 4 is basic first aid info. Section 5 covers firefighting measures. Oh no. We have to keep moving while you're doing whatever it is you're doing. Section 6, spill control measures. Section 7 is handling and storage. Those are pretty self-explanatory. Oh, good idea, David. Section 8 is one of the largest and most important sections of the SDS. The first part lists exposure limits set by regulatory entities like OSHA and recognized health science organizations, with specific references listed by country, state, and province. Okay, that's fine as long as you guys stay seated so we can see. The second part of Section 8 lists exposure limits for chemical byproducts produced during use or decomposition, biological exposure indices, as well as additional information regarding exposure guidelines, engineering controls, and personal protection. This section lists the basic material properties such as pH, flammability, etc. The next 2 sections, stability and reactivity, and toxicological information, contain information about the chemical and physical hazards. George, can you sit up front with David and Francis? Pardon me. These sections detail the variables affecting exposure potential, as well as potential effects of acute or long-term overexposure, including potential carcinogenic and reproductive effects. This information can be a useful reference for industrial hygienists, safety personnel, and/or occupational health professionals. Section 12 covers environment effects. 13 is about proper disposal. Ted, could you please sit down? Section 14 tells you how to safely and legally transport the material. 15 is important legal mumbo jumbo, and 16 is additional information, usually information about hazards that are present only when welding with the particular product. A Lincoln Electric SDS will also contain Lincoln's maximum fume exposure guideline. Everyone, please! Shh. Hopefully you've all learned how to read an SDS. Good evening, David. The following are some guidelines you'll need when working with engine-driven equipment. Number 1, fuel. I'm talking about gasoline, diesel, kerosene, propane. Fuel burns. That's how it works. So be careful. Keep your fuel away from fire or sparks. Turn off the engine before refueling. Don't smoke when refueling. And for heaven's sake, don't spill. If you spill, clean up in a manner that would make your mother proud. The rag you've used is now a hazardous material because it's soaked in gasoline or whatever fuel you're using. Throw the rag away the right way. Give the fumes a chance to disperse after you've fueled before you start up the engine or begin welding again. Gas fumes can explode too. Keep your welding arc away from fuel. Be sure and follow guidelines for proper fuel disposal. Shut off the fuel line before moving your equipment. This reduces the risk of a fuel leak. David, you don't think you need to shut off the fuel line? Do you want to end up like those stick figure guys, blown to bits? It's so easy to shut off the fuel line. Why wouldn't you do it? There's no sense in not taking a precaution that could save you or anyone else from injury or even death, is there? Don't be careless or lazy. It's simply not worth it. Engine exhaust sometimes contain small sparks. Most of the time, these sparks are not dangerous because they cool very quickly. But in certain circumstances, you may be required to install a spark arrestor. A spark arrestor is a small device that attaches to an exhaust pipe to trap these sparks. For example, when working in dry forested areas, on offshore oil rigs and refineries, spark arrestors are usually required. Become familiar with the regulations associated with your work environment and install a spark arrestor if you need one. Most electrical equipment, including an arc welder, contains switches, relays, and brushes which create very small sparks when operating. There is generally no danger with these sparks unless you are working in an area where explosive gas may be present or can escape, and you shouldn't be welding under these circumstances. Your welder has moving parts inside, most notably the cooling fan. This equipment is enclosed for your protection, so be careful when opening these enclosures. Lastly, always read the manual. That's what it's for. Someone worked very hard on that, and their work deserves to be put to good use. There's no sense in trying to figure something out on your own when the instructions are available to you. Good night, David. David, it is common to work with portable power generators, and OSHA, or your local safety regulatory agency, requires additional protection from electric shocks when you're using portable generators. This is where a GFCI comes in. David, what are you doing? GFCI is short for Ground Fault Circuit Interrupter. These monitor power cables for leakage to ground and will shut off power to the circuit if even the smallest leak is detected. They're more sensitive than circuit breakers or fuses. Remember, a shock of 120 volts can kill in certain circumstances, so it's important to follow the regulations regarding when GFCIs should be used. David, what does this have to do with GFCI? It's important to know the limitations of GFCIs. If a hot lead is leaking current to ground, an electric shock hazard may exist unless the power is shut off. And they do not prevent shocks if you receive the shock from touching two hot leads. They also don't prevent shocks from the welding circuit. GFCI is not a free pass. You must still use all the safety precautions we discussed in the electric shock module. David, what the... I'm just going to keep going. Is that okay? GFCIs are required on most outdoor and construction sites, and if you are using your own welder, you may be required to have the GFCI installed on your unit. Safety inspectors are out there, so be warned. Breathe in. Relax. Feel the earth beneath you. We're going to talk about grounding. What's that? Oh, I see, right. Yeah, that makes sense. Sorry, David, looks like we were talking about electrical grounding. Why don't you grab a seat? Electricity always finds the shortest, easiest path to ground, unlike David, whose head is always in the clouds. Under the right circumstances, David could be part of an electric current's path to the ground and receive an electric shock. We're going to talk about 3 kinds of grounding: earth ground, chassis ground, sometimes called frame ground, and welding ground, also known as work cable. Standing on a metal chair is not going to help you, David. But don't worry, nothing is going to happen to you. I promise. You can get down. This is the symbol indicating an earth ground. It's also usually indicated by a green wire or green screw inside your equipment. This symbol indicates a chassis ground. A chassis ground is a grounding to the frame or chassis of a piece of equipment, but the chassis must in turn be connected to an earth ground on another piece of equipment. Think of the chassis ground as an extension cord connecting your circuit to the earth ground. A welding ground is also called a work cable. It is connected from your welder to your workpiece, necessary to create a complete circuit in which the welding current flows. It is impossible to strike an arc on a piece of metal unless the work cable is connected. If you need more information, get a copy of the National Electrical Code and look up the article on grounding. This can be found at your local library or in most bookstores. I see by the green wire, David, that you are grounded. This is very good for meditating, but keep in mind, when welding, you want to insulate yourself from ground to prevent yourself from being a potential path for electricity to reach ground. Namaste, David. David, it's time we had a talk about carbon monoxide. Carbon monoxide is a byproduct of fuel burning. It can come from natural gas, propane, or gasoline. It's emitted by any engine-driven equipment you use. It can also come from the arc welding process. We are exposed to non-lethal levels of carbon monoxide every day. But outdoors, where it can dissipate, it's not directly harmful to us. In enclosed or poorly ventilated spaces, however, carbon monoxide can be deadly. It's why you don't run your car with the garage door closed. What makes carbon monoxide especially dangerous is that it's colorless and odorless. David, you could be sitting in a cloud of carbon monoxide right now. The initial symptoms of carbon monoxide poisoning are similar to the flu: headache, fatigue, shortness of breath, nausea, and dizziness. Relax, David. You are not in a cloud of carbon monoxide. You are perfectly safe. And we know this because we've installed a carbon monoxide detector. It's a good idea to install carbon monoxide detectors in your workshop or any space where you're working, and if your work area is not properly ventilated, harmful concentrations could build up. High-level CO poisoning results in progressively more severe symptoms, including confusion, vomiting, loss of coordination, loss of consciousness, and eventually death. Preventing CO poisoning is simple. Be aware of when it may be present and only operate engine-driven equipment outdoors. If you start noticing the symptoms, shut off the source of carbon monoxide if possible, leave the space immediately, and let your coworkers know. And don't return until the CO levels have been tested by a professional. David, remember your carbon monoxide detector? You're fine. Many welders are mounted on a trailer to be easily moved to a work site. Trailers are generally very durable and reliable as long as they are installed properly and regularly maintained. Oh, for heaven's sake, David! Make sure the weight of the welder you'll be towing does not exceed the trailer's capacity. Don't overload your trailer. David, come on. When mounting your welder to a trailer, check your trailer's specs and make sure you have the proper tongue weight. David! I'm not even dealing with you. Can we cut to an animation here? If your welder is mounted too far back, your trailer may sway while towing. If it's mounted too far forward, you may exceed the capacity of the tow hitch or coupler on your vehicle. Make sure you're towing the trailer in a level position. Attach your hitch or coupler in the proper way. Inspect and secure your trailer jack and any other equipment on your trailer, and use chains when going above 10 miles per hour. Inspect your tires for damage and proper air pressure. Make sure you don't exceed load capacity for the tires. Inspect your wheels, bearings, and lug nuts. Shut off the fuel line on your engine-driven welder before towing to prevent leakage. Connect your trailer lights and test them to make sure they're working. Adjust your mirrors. Tow at a reasonable speed. If the trailer is not stable or something feels off, pull over and check your trailer and hookups. There's no reason to take chances with your equipment or safety. If you're going to be welding in a confined space, remember that hazards associated with normal welding are multiplied, so special precautions need to be taken. In the US, OSHA defines an enclosed space under the following 3 criteria. 1. The space is large enough that an employee can enter and perform assigned work. 2. The space has limited or restricted means for entry or exit. And 3. The space is not designed for continuous human occupancy. Fumes accumulate more quickly in enclosed spaces, increasing the risk of harmful exposure, explosions, or potentially displacing breathable air. A metal enclosure can be very dangerous as it can become electrically charged. An insulating mat and other precautions should be used. Employers must provide training and supervision for work in confined spaces. Always make sure that spaces have been tested for safe oxygen levels and toxic gases before entering, and make sure you have the proper training. You should check out your employer's confined space procedures and local regulations. In the US, the OSHA document 20 CFR 1910.146. Can you remember that, David? Okay, I'll write it down for you. Let's go over some basics of how to keep your work area as safe as possible. It's basically like being a good roommate. George will be playing your roommate, David. First, maintain the guarding that comes with any machine or hand tool you use as it was originally intended by the manufacturer. If you want to express yourself, consider a tattoo. Leave your tools and equipment the way they came. Put your tools away after each use so they don't get in the way. Keep your work area clean and free of debris. This will minimize trip hazards and fire hazards, as well as just making a generally nicer place to work. Don't you think? Working at heights? Wear the proper harness and take necessary precautions. Look out below! Not just for people, but for combustible and flammable materials too. Sparks may fall farther than the usual 35-foot radius when working in an elevated area. Know where the emergency exits and evacuation routes are. Finally, understand your role in an emergency. David, it's not to push the panic button. Why do we even have that? Hey, David, want to hear some cool science? Electric current flowing through wires, equipment, and workpieces cause electromagnetic fields, or EMF. You can't see them or feel them, but they are there. Science does not yet know for sure if these fields are harmful, but it has been suggested that exposure to EMF from power lines, microwaves, and cell phones may have some negative health effects, including cancer. Though these claims have not been confirmed, it's a good idea to minimize EMF exposure while welding. Route your electrode and work cables together. Secure them with tape or tie wraps when possible. The EMFs are reduced wherever these cables are routed together. Never wrap cables around your body. That's just a bad idea for all sorts of reasons, EMF exposure being only one of them. Don't place your body in between the electrode and work cables. Make sure both cables are always on the same side of you. No sandwiching. Make your work cable connection as close to the point of work as possible. This minimizes the distance the current travels across the workpiece and therefore minimizes the EMF. Don't work directly next to the power source. The welder has its own EMF from the current inside the welder. No, David, those EMFs won't cook your dinner. Always weld at the lowest DC output setting acceptable for the particular job you're doing. This will minimize the EMF. One last thing. David, do you have a pacemaker or defibrillator? EMF fields can interfere with some pacemakers and defibrillators, so consult your doctor before welding if you have a pacemaker or defibrillator. Burns are the most common injury to welders. No, I'm not talking about the quick-witted insult type of burns. I'm talking about the fry your skin and char your flesh kind of burns. Welding arcs are very intense and can cause burns to skin and eyes with just a few minutes of exposure. Your protective clothing should provide good coverage from sparks, welding spatter, and arc radiation while allowing freedom of movement. If you leave a button undone, the arc will find it. Many types of clothing will protect you from ultraviolet radiation, but should never prevent ultra-hip choreography. When it comes to clothing, leather and wool are where it's at. Why? They are durable and fire-resistant. Avoid synthetics, not just because they're tacky, there's a practical reason too. When exposed to extreme heat, synthetics melt and can cause severe burns. Nothing is more embarrassing than having your shirt burst into flames when you're laying down the perfect bead on a steel girder 300 feet in the air. Wear leather and/or wool. Leather boots are the best foot protection. 6 to 8 inch ankle coverage. Consider safety toe protection if you're doing heavy work. Metatarsal guards over the shoelaces are smart too. What's metatarsal mean? You just need to know it's these things that go over your shoelaces. Fashion tip, don't roll up your sleeves or pant cuffs. Sparks or hot metal can get caught in the folds, and while that's a great recipe for some hilarious physical comedy, it's also very dangerous. Wear your boots like this to keep out sparks and flying metal. Not like this, not like this, and definitely not like this. Like this. Gloves. They're like 5-legged pants for your hands. Leather is the best material to protect you from burns, cuts, and scratches. And if they're dry and in good condition, they'll offer you some insulation against electric shock. Working with sharp metal? Look into cut-resistant gloves. Oh yeah, they're for real. Let's finally get to the reason you're becoming a welder. The helmet. Not only do they look super cool, they are essential to protect your eyes from radiation exposure and your face and neck from burns. You've got your infrared radiation, which can generally be felt as heat, and your ultraviolet radiation, which can't be felt and is therefore all the more dangerous. Infrared radiation can cause retinal damage and cataracts. Ultraviolet radiation can cause welder's flash, which can result in extreme discomfort, swelling, fluid excretion from the eyes, and even temporary blindness. I know it's tough to look at, David, but it's important for you to see this so you'll be prepared to protect yourself, because the worst part is, You might not even know you've got welder's flash for several hours after exposure. Welding helmets have a variety of shaded lenses to protect your eyes from infrared and ultraviolet radiation, as well as visible light from the arc, which can hurt your eyes in the same way that staring into the sun can. Many helmets these days have auto-darkening shades. Read those instructions carefully to figure out how to set that up properly. With other helmets, you can change the protective lens depending on the type of welding you're doing. The general rule is, find the lens where it's too dark to see the arc clearly, then back up one level to the next lighter shade. Shielded metal arc welding with a small diameter electrode generally requires protective shading of 7 and up, while processes like carbon arc welding require protective shading as high as 14. Read all the safety warnings and guidelines to make sure you're being properly protected. Repeated exposure to UV radiation can cause permanent eye damage and skin cancer. Like getting a sunburn, this happens slowly over time, and you won't always know you're being overexposed because you can't see or feel the UV rays. Contact lenses should be fine, but do your homework. Talk to your ophthalmologist and company medical staff. And you know what? Probably don't wear contacts in really dusty environments or where there's danger of chemical splash or exposure to corrosive or organic solvent vapors. Safety glasses are a great way to look smart and appear as though you know what you're doing. They also offer extra eye protection. Protect your ears with earplugs or ear muffs. This keeps flying particles from damaging the inside of your ear and protects your hearing. Prolonged exposure to loud noise can cause hearing loss. So if the noise level is painful or loud enough to keep you from hearing your colleagues speak at conversational volume, you need ear protection. And please, don't use dirty earplugs.
When airborne contaminants are present, when exposure levels are high, when ventilation isn't enough, you need a respirator. Before you get a respirator, a safety and health professional will evaluate the types of contaminants and the concentrations you'll be exposed to, so they can determine the right respirator for the job.
Can we stop for a second? I see what you're doing here, it's cute, but to be honest, David, a fake movie trailer? It's a little 2008, don't you think?
Okay, let's take it from the top, everyone.
David, please.
Lights.
David.
Camera.
Don't make me pull rank.
Action.
Cut. My apologies, everyone. Let's continue with a review of the types of respirators. Believe it or not, a dust mask is technically a respirator and subject to regulatory requirements. It's easy to use and disposable, as its functionality diminishes over time when it's being used. David, really, this is important material. I know I promised you could be in charge of this segment, but we have important ground to cover, and you were making a mockery of it. Okay, David, why don't you show everyone how to put on a dust mask, and then you can walk us through the next segment.
Disposables can only remove airborne particulates and are categorized as such. This chart shows the efficiency rating system of various respirators. The number in each designation corresponds to the percentage of efficiency, while the letters N, R, and P represent the filter's resistance to oils, with N having no resistance, R having medium resistance, and P having high resistance.
I'm sorry, David, but just watching you talk is boring. I think we have a good system where I talk and you demonstrate.
Yeah, you're right.
Let's continue then, shall we? A dust mask should be used to filter airborne particulates, not gases and fumes. To filter air containing gases and fumes, you'll need to step up to the next type of respirator, the negative pressure respirator. In this type of respirator, the wearer uses his or her own respiratory force to move air through the respirator. David, I appreciate your enthusiasm, but remember, you should be able to breathe normally through a respirator. In fact, before being issued a respirator, you'll have to get a medical clearance evaluation to make sure wearing a respirator won't interfere with your ability to breathe properly. Now, some of these respirators use replaceable cartridges with filters and chemicals to absorb gases and vapors. Different vapors and gases require different chemicals and compounds to absorb them, and your industrial hygienist will select the right respirator and, if necessary, the right cartridge. Need even more power? Then you'll step up to a powered air purifying respirator. These use a motor to pull air through filters and/or cartridges to deliver purified air directly to you through a headpiece breathing tube. Bonus, the movement of air helps keep you cool and comfortable. The last type of respirator is supplied air. Pressurized, clean breathing air is supplied through an airtight hose to special headgear. Although there are certain types of underwater welding that are done in scuba gear, you really don't need the flippers, David. Depending on the respirator you'll be using, you may have to have a fit test. Not that type of fit, David. A test to make sure the respirator fits you properly and will provide the right protection, which you've clearly done, David. The suit looks great on you. Today, we're going to talk about CNC plasma cutting. Let's start with a basic review of electric shock, which we now know can hurt or even kill. CNC plasma cutting machines produce high voltage, so please be careful. David, in front of you are two electrically hot wires, and you know what to do with those, or rather, what not to do. David, the rule is don't touch them. You'll complete the circuit, and David, please don't do that. David, can you hear me? Please don't! Oh, thank goodness. David, that's not funny. Okay, it was a little funny. Now let's review the other safety precautions against electric shock. Appropriate protective clothing, gloves, dry of course. Keep your distance from the workpiece and other parts of the plasma cutting circuit. Take extra precautions when the workplace is damp or moist. David, no! Don't you know it's bad luck to open an umbrella indoors? Now I'm just messing with you. Disconnect the power source before performing any maintenance or repairs. Only a qualified technician should repair or replace any worn or damaged parts. Very good, David. And yes, always read and follow all the instructions in the operating manual. Fantastic. That covers electric shock. Let's talk about gases and fumes. David, I know you're joking this time. Plasma cutting produces gases and fumes that can be very dangerous to your health. First thing is always what? Keep your head out of the cutting fume plume. Always work in a well-ventilated area or use local exhaust to extract fumes. Use an approved air-supplied or powered air purifying respirator if your ventilation is not adequate. How do you know what kind of fumes and gases you'll be exposed to during plasma cutting, you ask? This all depends on the kind of metal being cut, the coating on the metal, and the exact process being used. Read the SDS for the material being cut and any paint or other coating. But it's not just gases and fumes you have to be aware of. Dust created by routing, sawing, grinding, drilling, and other construction activities may also be dangerous, and you should avoid overexposure. I'm afraid that's not really going to help, George. Many of the materials can cause cancer and other health effects if your exposure is not properly controlled. No, David, that's not going to help either. You can use special equipment like downdraft and water cutting tables to capture gases, fumes, and dust at the source. And you should also limit your exposure to these particles by wearing the personal protective equipment we've discussed. You can also be exposed if dust gets on your skin, so wash any exposed areas with soap and water. Now that's sweet. Who's got a camera? Cleanliness is important. But keep in mind that vapors from chlorinated solvents and cleansers can react with heat or radiation from the welding process to produce phosgene gas, which is toxic. So be sure to get rid of any source of these vapors before work begins. Next up, fire and explosions. Fire and explosions can be caused by hot slag, sparks, an oxygen-fueled cutting flame, or a plasma cutting arc. so be careful. I'm not talking about quaint little campfires, guys. This is dangerous stuff. Do not work in an area where combustible or explosive gases or other materials may be present. Remove or protect any flammable materials and ventilate any explosive or flammable vapors or dust from the workplace. Don't cut or weld on containers that may have held flammables or combustibles. Use a fire watcher buddy when working in areas where fire hazards may exist. The fire watcher may see a fire that you don't because you are welding. Do not cut aluminum alloys underwater or on a water table unless you have a way to eliminate or dissipate the hydrogen gas that can be formed when cutting aluminum alloys. Trapped hydrogen gas will cause an explosion if ignited. It's very dangerous. Plasma cutting and CNC operation can cause very loud noise levels that can damage your hearing. Protect your hearing with earplugs and/or earmuffs. Noise should be measured to be sure it does not exceed safe levels. I said, noise should be measured to make sure it does not exceed safe levels. Noise should be measured to make sure it does not exceed safe levels! Oh, for heaven's sake. Let's move on to protecting your eyes. The plasma arc process produces very bright ultraviolet and infrared light. These arc rays will damage your eyes and burn your skin if you're not properly protected. This is where the cool helmets come in. Make sure you have the proper shade in your helmet and wear safety glasses with side shields, goggles, or other protective eyewear. There are lens shading guidelines that you can reference at lincolnelectric.com, such as Z49.1. Because it's computer controlled and very precise, CNC plasma cutting may seem contained and clean. However, metal cutting and marking operations can create a lot of dust and flying debris. Protect others in your work area from both UV and infrared light as well as flying debris by using booths, screens, or shields. Welding and plasma cutting produces EMFs. Keep the torch and work cables together as much as possible and away from your body. Though the long-term health effects of EMFs are unclear, we do know that EMFs can affect defibrillators and pacemakers. So if you have either of those, be sure to consult your doctor. CNC plasma cutters are big, heavy machines with lots of moving parts. Watch out for gears, belts, drive screws, and drill bits. The machine moves automatically and sometimes can move without warning. Beware of crush points. Keep loose clothing and cables secured and safe from moving parts. These machines and their components are heavy. Use proper lifting technique and team lifting when necessary. Certain tools use compressed air lines. These lines are under pressure. Hot sparks or flying debris may cause damage. Ensure these air lines are kept free from punctures, burns, or other damage or defects. Inspect compressed air lines periodically and repair or replace when damaged. Be sure any compressed air guns used for cleaning meet OSHA or your local authority's requirements for pressure chip guarding and noise. Never place an air gun nozzle or direct the airflow toward your body. That can cause an air embolism which can be fatal. And last but not least, remember that an oxygen-fueled cutting flame can reach temperatures of up to 6,330 degrees Fahrenheit, while plasma arcs can reach up to 45,000 degrees. Materials will be extremely hot after they've been cut, so wear protective gear, use a material handling apparatus, and wait for materials to cool completely before attempting to move them. Don't worry, guys. As a cartoon character, Stu is fine. But remember, only trained individuals should work with, on, or near CNC plasma cutters. Hello, David. We are going to talk about cutting system safety. Most accidents can be prevented with proper handling of equipment and regularly scheduled maintenance. Always take all the proper safety precautions and follow all guidelines. That's your first line of defense. David, since discipline isn't exactly your strong suit, we've brought in a drill sergeant and your mother-in-law to help keep you in line. We're going to be reviewing the safe handling of cylinders, regulators, and torches. Most accidents involving welding torches are the result of reverse flow. When the torch fuel gas enters the oxygen stream, or when oxygen enters the fuel gas stream. These gases are meant to mix at the tip of the torch only, and when the gases mix in an unwanted place, it's like running into your mother-in-law at a dance club. Not only awkward, it could cause a fire or even explosion. So on second thought, it's nothing like that. It can be much worse. When these gases mix in the wrong place, a small spark or extreme heat can cause a fire that can severely burn you, or even an explosion, which can kill. There are several things you should always keep in mind to prevent reverse flow. First, never fully empty an oxygen cylinder. Once you reach about 50 psi, consider your oxygen cylinder tapped out. If the pressure becomes too low, you have a potential for reverse flow if your fuel gas pressure is low. An oxygen tank is like your mother-in-law's glass. Never let it become empty. Refill or replace it. Second, bleed your hoses independently by quickly opening and closing each valve one at a time before lighting a torch. This will bleed off any combustible mixture in the hoses or regulators. Remember, the oxygen line is green and the fuel line is red, and the valves are threaded differently. This is all to help you remember which is which and not to mix or confuse them. Use the correct tip size for the pressure you're using for your application. Small tips with too much pressure can cause reverse flow and push mixed gases back into the line. Large tips with not enough pressure can cause flashback. And keep your tips clean. A clogged tip can cause reverse flow too. Sergeant, that's not really necessary. Many torches have check valves installed between the hoses and the torch handle. These prevent reverse flow. However, they must be maintained regularly. If they malfunction and reverse flow occurs, they will not stop a fire or explosion. Flashback arresters can also be installed. These prevent a fire from working its way back up into the gas lines. Again, they need to be checked regularly, or else they may not work properly. Here are some basic protocols to follow when setting up your equipment. 1. Chain cylinders in place to keep them from falling over. Vent the oxygen cylinder by briefly opening and closing the cylinder valve before attaching the regulator. This blows any dust or dirt out of the cylinder valve. Check the regulator inlet for dust and dirt. This can be fuel for a fire. Get rid of it. Open the oxygen cylinder valve slowly and stand to the side when doing so. Due to complicated physics, a sudden change in pressure to gases can cause heat. In some cases, enough heat to ignite a fuel-oxygen mix. Keep your torch away from combustibles. I mean, this one seems obvious. However, okay, it's just obvious. Do not use oxygen from the oxygen cylinder as a substitute for air. If you blow your clothes off with oxygen, the material will actually absorb the oxygen. If a spark or other ignition source comes in contact with your clothes, you'll go up in flames. If you want to have a bonfire, go camping. Never use flammable liquids such as oil or gas around or on your equipment. Don't handle your equipment with greasy hands or gloves. It's just a recipe for disaster. Speaking of recipes, that looks delicious. Save some for me, guys. Don't use regulators or pressure gauges from an oxygen cylinder on a cylinder containing fuel, or vice versa. This could cause a mix of fuel and oxygen in a place you don't want them mixing. Always turn off your torch, regulators, hose, and cylinders when not in use. Regularly use a soap and water solution to check the threaded connections at the torch, hoses, and regulators to be certain none are leaking. In summary, David, read the instructions, follow all the safety precautions, keep your tools, gear, and supplies in good working order, and maintain and clean them regularly. Develop and follow safe work habits and never cut corners, and you should be good to go. Congratulations, David, you're done. I hope you've had fun. I know I sure did. It was a pleasure to get to know you and to watch you learn and grow throughout our series. If you ever want more information, be sure to go to lincolnelectric.com. That about does it for me. Happy trails and safe welding. We should do lunch sometime. I'll call you. Do me a favor, lock up when you're done, okay? Bye-bye. Toodles.